Okay, in the next question, you're given three graphs there indicating the boiling points as the molecular mass of the substances they increase. So P clearly has the biggest boiling points, followed by R, then S. Remember, the high boiling point is indicative that the substance has stronger intermolecular forces, so that the stronger the intermolecular forces, the higher the boiling point. Yes, we'll get to that in a moment. Going to the first question, it says define the term boiling point. Now, the boiling point is defined as the temperature at which the vapor pressure of the substance equals the atmospheric pressure. Take note that those words that are underlined, temperature, vapor pressure, and atmospheric pressure, should be in your definition, failing which 1 mark will be deducted for each word missed. Yes, then going to the next question, write down the conclusion that can be made from curve P. Now, curve P, as you see there, it is the one that has the highest boiling points. And we are, according to the question, we are comparing carboxylic acids, aldehydes, and alcohols. So out of those three, we know that carboxylic acids have hydrogen bonds, which are the strongest. On top of that, carboxylic acids have two sides in which the hydrogen bonds can occur, compared to the one side in alcohols. So carboxylic acids will have the strongest intermolecular forces because, in fact, carboxylic acids are more polar than alcohols. So it's carboxylic acids, strongest intermolecular forces, followed by alcohols, and lastly it's going to be aldehydes. So if we are to interpret what is the curve P, we will see that curve P represents carboxylic acids. Why? Because for every molar mass, curve P has the highest boiling point. So 3.3 wants you to put that into perspective to explain that curve P has the highest boiling points, meaning that it has stronger intermolecular forces and therefore more energy needed to overcome the intermolecular forces. So 1 mark will go for stating that curve P has the highest boiling point and therefore the strongest intermolecular forces. Second mark, the strong intermolecular forces need more energy to overcome the intermolecular forces. Then going to the next question, which is 3.4. Curve R represents the alcohols. Which homologous series is represented by curve S? Okay, if the middle graph is alcohols, then obviously the one with the lowest intermolecular forces or boiling points is the aldehydes. So curve S represents the aldehydes. That's 1 mark for that. then you have to give the reasons why you are saying that. You have to explain. We are at 3.4.2. You would say that aldehydes, which is Cav S, have the weakest intermolecular forces. And they are weaker than in alcohols and carboxylic acids. Therefore, aldehydes have the lowest boiling points, meaning that they need less energy to overcome the IMF. So, people, you always have to state the type of force. You have to always state the strength of the IMF. And lastly, you have to tie everything with the notion of energy, that if a substance has stronger intermolecular forces, it requires more energy to overcome those for it to boil. Then getting to the next question, it says that for Cav R, write down the molecular mass of the boiling point of 97 degrees Celsius. Okay. Now, if you read out the scale correctly there, you would see that 97 is between the last a square before 100. Now, why are we saying that? It's because if you have 10 going up to 50, then it means each one of them is 5. So this is what the last one here represents 95, and in between, that's where you have 97, in between 95 and 100. And if you draw a straight line from there and down to the molar mass, you'd see that it goes to 60 degrees. When you draw that graph, that line there downwards, it goes to 60. So the answer there is that substance has molecular mass of 60 grams per mole, and you get 1 mark for that. Okay. Now, the next question, 3.5.2. Okay. You were to work out the IUPAC name of that substance that has 97 degrees Celsius, that has a molar mass at 60 degrees. Okay, to do that, this is the general formula of alcohols, CnH2n plus 1OH. Now, if we keep on substituting 1, 2, and 3, you'll notice that when you get to the third carbon, the relative atomic mass becomes what? 3 times 12 plus 8 times 1 plus 16, giving you 60 grams per mole. And a 3 carbon alcohol is propanol. But we are going to specifically give it as propan-1-ol because in the question, it stated that the substances are straight-chained substances. Yes, we'll take it from there in the next video.